One of our classmates asked a question about negative exponents or the quotient rule, out of 12.1. So this is again for MATL 0014, right? And so the question was, when we have something like this, I'm just going to make up a problem here, y'all. X to the 8th divided by, say, x to the 5th. So here we know that our exponent on top is bigger than the one on the bottom, right? So again, just to give you a heads up, guys, look what I'm going to do here. 1, 2, 3, 4, 5, 6, 7, 8 on the top. 1, 2, 3, 4, 5 on the bottom. So what ends up happening is we can start to cancel these, right? So how many x's are we left with? Oh, we're left with 3, right? Now the question is, what happens if we have a similar problem, but it's reversed, meaning the exponent on the bottom is bigger? Well, I can actually do the same thing. Look, 1, 2, 3, 4, and 5, and 1, 2, 3, 4, 5, 6, 7, and 8. And now I can go 1, 2, 3, 4, 5, and look how many x's I'm left with. I'm left with 3 x's, but they are on the bottom. Now, y'all, I don't see it here, but remember, the number in front of that x is really a 1. Right? Okay, so the second question is, how does something like this, or how does something like this become something like this? Okay, so if I think of this over 1, if I have a negative exponent, and the negative exponent is on the top part of my fraction, I can bring this guy down. My exponent's going to become positive because I am now bringing it to the bottom, okay? And then the last question was, when we're doing the scientific notation business, right? We're doing the part on scientific notation. So let me just make up a problem here. I'm going to write 1285, right? So the question might be, well, how do I write this in scientific notation? So remember, the first number here, y'all, is going to be a number that's more than $1, but less than $10. So I'm going to think of my decimal point. It's always at the end, right? So I'm going to move it over here. That gives me 1.285, right? More than $1, but smaller than 10. Now, because this is a big number, think about it like money, 1285, right? $1,285. Because that number is big, my exponent's going to be a positive number. Positive 3. Why 3? Because I moved it 1, 2, 3, right? So now, let me give you a second example. What about something like 0.0032, okay? I'm going to write this in scientific notation. So remember, the first number is going to tell me move my decimal there. Why? It has to be a number that's more than $1, but less than 10, right? Now, this number here, y'all, is pretty small. If I were to think about, and you say, what do you mean by small? Think about this again in terms of money. This is not even a penny, right? This is like a fraction of a penny, okay? So how many spaces did we move our decimal point? 1, 2, 3, 4, right? Because it's a small number, it's going to be -4. Now, again, the question is, well, what does it mean to be a big number? What does it mean to be a small number? A big number, y'all, just means it's going to be more than 1, right? Or more than 10 or something like that, right? Small numbers are usually starting off with a 0 in the front, okay? So even if I have a number like, say, 15, and I want to write this number in scientific notation, 1.5, right? Because it has to be a number bigger than 1, smaller than 10. 10, remember, my decimal was here. How many spaces did I move it? 1. Why is it a positive 1? Because 15 is kind of a big number. Big in the sense that it's more than 1, right? Does that make sense? Anyway, do y'all have any questions? Let me know. I'm happy to help.